This topic is called the library of functions, and library basically means a collection of. And this video is not so much about learning, it's more about memorizing. And these are the functions I'm holding you responsible for knowing what they look like. And when I say knowing what they look like, I actually mean having the coordinates correct. So the first one is the linear function y equals x. You can call that also the identity function because y is x and x is y. And you can see that it is just going to kind of cut our coordinate boxes right in half, meaning every coordinate, the x and the y, are exactly the same, which makes total sense for y being equal to x and x being equal to y. Of course, we should know what our y equals x squared function looks like. We can also call this a quadratic function. We know that those are happy faces. And to get these coordinates, you're really just plugging your x values into this function or squaring it. So if I get 1 squared, I get 1. Take 2 squared, I get 4. Take negative 2 squared, I get 4. Take negative 1 squared, I get 1. Okay, the next function is the cubic function, which kind of looks like a wiggle or, some person doing a little dance. And on this, we need to find a few points. The first one, if I plug in f of 0, plugging in 0 in for x, I get 0 cubed. So this is the coordinate 0, 0. Then plugging in 1, well, what's 1 cubed? Well, that's going to be 1 times 1 times 1, which is 1. And then what is 2 cubed? Well, that's 2 times 2 times 2 is 8. What about negative 1 cubed? That's negative 1 times negative 1 times negative 1. That's going to give me a minus 1. So we've got our 0, 0. We've got our 1, 1. We've got our negative 1, negative 1. And then 2, 8 is way up off the graph here. Probably even higher, actually. But it does exist, as you can imagine, kind of way up here. Okay? All right, let's look at some more. All right, this next one is called the reciprocal function because it's 1 over x. It's the reciprocal of x. And this function is going to look like this with an asymptote, which means it gets really close to the x-axis but doesn't hit it. And here it gets really close to the y-axis but never hits it. So I'd certainly like you to put arrows on yours because it does go on forever. And again, this is getting close to the x-axis right here, but it never hits it. And then same thing here. It gets really close to the y-axis but never hits it. And then you need to be able to identify 2 points on there, and the first being 1. If we plug 1 into here, we get 1 divided by 1, which is 1. And now let's let x be negative 1. Plug that in. 1 divided by negative 1 is a negative 1. And that's why I have this coordinate and that coordinate. The next one is the square root of x graph, and this is what I think of as half of a seagull, or maybe an angry eyebrow. Right, see, I'm so mad. How do we get these coordinates? Well, what's the square root of 0? Well, that's equal to 0. So you've got the coordinate 0, 0. What's the square root of 1? That's 1. So you've got the coordinate 1, 1. What's the square root of 4? It's 2. So you have the coordinate 4, 2. So there are my 3 coordinates. Now, y equals, or f of x equals the cube root of x looks really similar to x cubed. In fact, they're inverses. They're reflected over the line y equals x, but they do look different. It's kind of like a different dance move for this person. Or maybe they've got like a sword and their hair is flying back. I don't know. Get a little crazy, you guys. So how can we find functions here? Well, what's the cube root of minus 1? Well, that's equal to negative 1 because negative 1 times negative 1 times negative 1 is minus 1. So that gives us our coordinate minus 1, minus 1. Cube root of 0 is also 0 because 0 times 0 times 0 gives me 0. So that's the coordinate 0, 0. And the cube root of 1 is obviously 1 because 1 times 1 times 1 gives me 1. So that's equal to 1, comma 1. Oopsie. All right, so now the next function that I want you to know is 1 over x squared. And again, when you're drawing this for your notes, I want you to put arrows. We have 2 horizontal asymptotes, meaning we actually have 1, but approaches in 2 different directions. So we've got the horizontal asymptote, which is being approached from both sides, and then you've got this vertical asymptote where you can see that it's getting closer and closer, but never hits it. So make sure you have your arrows on there. And then we also have the function e to the x, and what I really want is for you to make sure you have this point 0, 1. And if you don't believe me, if I do e to the 0, anything to the 0th power is 1, so this is going to be the coordinate 0, 1. Okay, and then the next one is ln x, which is actually the inverse of e to the power of x. You can think of this as log base e of x if you want. And we certainly know that this coordinate here exists as 1, 0. And one of the reasons we know that is because these are inverses, e to the x and ln x. So if we just swap this coordinate, the x and the y, we get our 1, 0. And I'll talk more about inverse functions later. All right, the sine x function, the cosine x function, and the tangent x function. So for sine, what I want you to know is it starts at 0, 0. It hits the x-axis at pi, and then it comes back and hits the x-axis at 2 pi. So you start your curve up, and it goes all the way up to 1. And then you start your curve again, but this time going down, and it reaches -1 as its lowest point. Okay, we call that the amplitude from -1 to 1. And so for me, for the sine function, it's really important that you know that it starts at the origin, it goes up to 1, hits the x-axis, goes down to -1. And this is from 0 to 2 pi, and this value right here would be the pi. And we should know that this is pi over 2 and this is 3 pi over 2. And if you think about that, that makes total sense because you're cutting 0 to pi in half. That's why it's at pi over 2. And then this is a 1 pi and a 2 pi, so obviously this would be a 1½ pi, which is the same thing as 3 divided by 2. Now in the cosine function, it actually starts at 1, goes down to -1 by pi, and then ends up at 1 by 2 pi. So what I really want you to memorize is for the cosine graph, you start at 1, it goes down to -1 when it's at the halfway mark, and then it finishes up back at 1. Remember, we're talking about from 0 to 2 pi. This halfway mark would be pi. By the time it hits the 0, you're at pi over 2. And this time you hit the 0 again, you're at 1½ pi or 3 pi over 2. All right, now this tangent graph, I want you to add asymptotes in. And I want you to add arrows as well, because this tangent graph, again, approaches this vertical asymptote, gets really, really close to it, but it never hits it. There we go. And I think it's important to note for tangent that you, at the origin right here, your point 0, 0 exists. That always helps me remember what the graph looks like and where my asymptotes are. Now, these two functions right here, the cosecant and the secant function, I'm not going to have you memorize, but there are asymptotes here, there are arrows here, etc. And so you're welcome to get this down. I will never quiz you on it, but I do think it's necessary that you see it at some point in your math careers. And we can talk more about what secant and cosecant are in terms of trig, but for now, you should just be able to recognize this graph if you need it. Now I zoomed in there. All right, and the last one is the cotangent function. And again, you've got asymptotes here. And I can put arrows, and I'm not going to have you memorize this one, but like I said, it's important that we know in general what some of these trig functions look like. All right, that's it, and I hope you have a good day. Peace.